So this is about characteristics of a graph. So this is your graph right here, obviously. Which point is the vertex? It's something, comma, something. You kind of just need to look at it and figure out what point that is. 1, -4. Good job. That's all there is to it. You basically just need to know what vertex means. It means the center point. Now, axis of symmetry is new for you. That's that vertical line that's dotted in. Do you see that there? What does the word symmetry mean? Both sides the same. Like if you folded it, it would be the same. Now that's a vertical line. Do you remember hoi vux? Vertical means it is x equals, okay? So your axis of symmetry is always going to be x equals something. It's always going to be a vertical line. That's vux. What does the U stand for? Undefined. Good job. I knew what you meant. I'm not going to yank you in the hall and make you take like a oral exam here, okay? So x equal. Now, where is that line? Don't overthink this. Just what number is it at? 1. 1 comes before 2. All right. But you're awake and listening to me, so I'll take that. All right, x-intercepts. There's 2 of them. What's this first one? -1, 0 is one of them. And then, good, thank you. 3, 0 is the other one. Y-intercept, down here, 0, -3. Good job. And is it a maximum or minimum? This is more vocabulary, but don't overthink this. Maximum means the biggest. Minimum means smallest. Now, it is a minimum because it's the smallest point on the graph. Now, we're going to review domain and range. It's been a minute since we've talked about that, so I need for you to extra listen to this part. So I feel like I'm hearing talking while I'm talking. If you're talking, you're not listening. What is that saying? God gave you 2 ears and 1 mouth, so you could listen twice as much as you talk. Now, there aren't arrows on the ends of this, but you can go ahead and put them. I'm going to wait till you're done talking because I'm not rude and I don't talk over people. I know it looks like the arrows are pointing down, but do you see how this is going to go off the paper and then off the table and like down the hall? It's going to keep going forever and ever. So it is going to keep going left and right forever. This is how we write everything. We have done this earlier this year. It's just been quite a while. Domain is X, range is Y, okay? So for domain, it's X, a little E, that means element of, R means reals. This is how we write every real number. It means everything. We have done that, whether you remember it or not. Does anyone sort of remember the little sideways E thing? Okay. Range. Range is Y, and domain is X, range is Y. Can you guys watch me point to this? Good job. What Y value is the graph stopping at up here? 4. Do you want everything above 4 or below 4? Do you see how it's everything below 4? Okay, so it's Y is less than or equal to 4. If it was above, you would say greater than or equal to. Okay. What is your vertex point? It's this coordinate right here. So it's something, comma, something. It's something, comma, something. So you need X, -3, 4. There we go. Well, there was a lot of talking, so I just didn't hear you. Now, is that a maximum or a minimum? Maximum. It's the highest point up there, like the top of the hill. All right. The axis of symmetry is a vertical line. If you want to dot it in, you can. It's that line that splits it in half. It's vertical, so vux, it's going to be X equals, good, -3. All right, x-intercepts. We've got 2 of them. One right here. Good. -1, comma, 0. -5, comma, 0. They have to be ordered pairs, so you need like 2 numbers there. And then y-intercept is all the way down here. Yep, 0, -5. Good job. We're just going to try that a couple more times on the other side. Everybody stay focused and we'll get through it nice and quick. This isn't that hard, right? No. Now this one, there isn't a graph given. So I am going to go to my calculator and type it in. Can you guys just watch, make sure I don't type anything wrong? Need to make a connection between what I'm saying to you right now and the classwork you're going to do later. If you listen to me, then you'll know what's going on. All right. Different points that we need. We need our x-intercepts. Here they are. I'm going to click on them. Those 1 and 3. Can you do that for me? 1 and 3. If you can count to 3, you can do it. All right. What other points do we need? The vertex, which good, is 2, -2. So go ahead and plot that. And then one more. Good. 0, 6 is your y-intercept. So those are all your like important points. You can certainly do more. I mean, you can click anywhere else on the graph. Those are the important ones. And then go ahead and connect them. Again, it's a parabola, U shape. And then we're going to use that to answer all the questions. Did she have it ready for you? All right, domain, listen to me. I know it looks like these are pointing upwards, and they kind of are, but do you get that they're going to go left and right forever? It's going to keep spreading out forever. All reals. That's the answer. The domain is going to be all reals. Like on your test, that's the answer. I can't change that. Range is y. That will not be all reals. Just watch me point to this. I don't have a better explanation than, hey, look. All right, what y value is this stopping? -2. Do you want everything above or below? Above. So greater than or equal to -2. You are so smart. You listen to me, you're going to know what's going on. All right, our vertex with 2, -2. I clicked on that on Desmos. Is it a maximum or a minimum? Minimum. The low point. Hey, can you write this down? Axis of symmetry. It's a vertical line. So that's Vux. It's going to be x equals, and I dotted it in. It's at 2. Please don't overthink that. It's just what number that's at, the center. X-intercepts 1, 0, 3, 0. I just clicked on those on Desmos. You're going to just use your calculator. And then your y-intercept, and what I want you to notice, it's the c value in your equation. You can look at the graph and see that that's at 6, but do you also see it here? 0, 6. I want you to make that connection. All right, we got one more of these. I'm going to share my screen. You guys look up here. And let me just alter this so it's the new equation. X squared. Hey, can you focus for me? Shouldn't have to say be quiet. Write this down. Please focus over and over and over again. Let's just, come on, guys. All right, vertex right there. -3, 0. So go ahead and plot that. Now that's not only the vertex, it's also what? Also the x-intercept. There's only one x-intercept. And it's going to be the axis of symmetry. It's kind of all those things, some sort of special. Now I need one other point though. What other points do I need? The y-intercept, it looks like 9, 0, 9. Wow, that's like practically off the grid. All right, and then it's doing something like this. Mine doesn't look very good, but that's okay. Not here to grade your art skills. Are you with me? I'm recording this, so you can always watch the ones that you missed. Just pick up on the one that we're on. Now, what's the domain? I just told you it's the answer. Yep, all reals. Graph goes left and right forever. It's going to be everything. That's the answer. It's an automatic answer. Now, hold on. Let me get everybody there. It's y for range. What y value, and this is a little tricky because it's on the axis, 0. Do you want everything above 0 or below? Above. Good. So greater than or equal to 0. Your vertex, close, -3, 0. Is it a high point or a low point? Maximum or minimum? Minimum. Good job. Your axis of symmetry, if you want to dot that in, my graph doesn't look very symmetric because I didn't draw it very well, but x equals -3. Good job. Yeah, good. It's because the x-axis, like that ended up being where the vertex was. And then your y-intercept was 0, 9. And again, that's your C value, this number right here. And then after you do this one, we'll do a break, but you guys need to listen to me. Draw an example of a quadratic. That's what we're doing, by the way. These are not linear. They're not lines. They're called quadratics with no x-intercepts. How could you do that? How could you draw a U shape that doesn't touch the x-axis? Yeah, like just stay above it like that. Now, hold on a second. There's another way you could do that. What's the other way you could draw a U shape that doesn't touch the x-axis? Yeah, you could draw one down here. Do you get what I'm saying? Like two options kind of for that. No, it wouldn't. So let's review our parent function. A parent function is one that hasn't been changed at all. Like it's still centered at 0, 0. So for x squared, I haven't been super specific about all the points as kind of like, as long as we get all the important ones, we're good. Let's take a minute and plot, kind of everything here so you can see all of it. I'm just going to type squared. Let me show you this. Watch. This will be helpful for you if you need all the points instead of just the ones you can click on over here. Are you looking? I hit the gear, then the table, which you've done before. Do you see how all these points show up? We're going to go ahead and plot those. You type in the function, it's gear table like you've done before. So what's your first point? If you're in the back, you might not be able to see it, but well, 0, 0 is there in the middle, but what else? -2, 4. So go ahead and plot these. -2, 4. And as soon as I get back to my other screen, I'll change the passes. -1, 1. Do you see that there? -1, 1. 0, 0. 1, 1, and 2, 4. Hold on, because I can't have my paper and my calculator up there at the same time, but these were those points. So you can always type it in and make a table and get all your points. Okay, now we're going to graph squared plus 3. So watch what happened. Basically right now, all I want you to do is watch and absorb what's going on. I'm going to get rid of this table. Are you looking? Now look, it's almost the same. Here, let me get our points and we'll graph it. -2, 7. Can you plot that for me? I can't have my paper and my calculator up here at the same time, so you're gonna have to listen and kind of take care of some of this on your own. -2, 7. We've got -1, 4. 0, 3, which is the one I really want you to notice. Do you see that? Instead of 0, 0, now it's 0, 3. You've got 1, 4, and you've got 2, 7. Are you also noticing the symmetry? Like that's the other thing that you kind of need to notice here. So it's going to go like this. I've got it right here. I can't have them both up at the same time. That's what we're going to talk about. Okay, so just hold on. And we might not answer every single one of these questions. I don't need for you to answer all of these, but we just need to understand what happened to the graph. So here is the big question and the thing you need to notice. Where is this one centered? 0. This one is up. Good. Thank you. It went up 3. Now, I don't need to necessarily answer all of this. We did a whole lot with vertex and axis of symmetry on the other side of the paper, so I don't necessarily need that. But here is the takeaway. If it was x squared minus 3, what do you think it would go down 3? I'm going to just make up a couple more. Now, since I didn't make you do all the rest of those questions, I want you to write these down with me. Let's say it was x squared plus 17. How did it get transformed? Transformations is what we're doing here. What do you think happened? It went up 17. The whole U shape, you just took it and moved it up 17 spaces. How about x squared minus 12? Down 12. There, have we got it? Plus is up, minus is down. Thank you. Please work with me, okay? If you add something, it's going to move the graph up. If you subtract something, it's going to move the graph down. Oh, I just made up a few more examples. I was just making up a couple more examples. Those were different. I was just basically like if this was part E, it's like I called this F and I called this G. I just made up a few more examples. Are you understanding what I'm saying? Okay. All right, looking at this one. This is where I need you guys to watch and focus so you can understand what happened. Let me get rid of all this. All right, this time there's a 2 multiplied out front. Let's go ahead and graph our points. I'm going to hit gear table. Can you all go ahead and plot those? Again, I can't have my paper and my calculator up there at the same time, so you're going to have to pay attention. We got -2, 8. Can you see this up here? -2, 8. You see that right there? Yes, 0, 0. That's interesting. The center didn't move. Well, I need for you to just notice what's going on. It's not that hard if you just pay attention. Okay. But the center didn't move. It didn't get shifted up or down, but something did happen to it. If you compare that graph with the original one, what happened? Like the center stayed. It got taller. Good job. We call this a stretch. It got stretched to twice its size. So it is a stretch. Oops, I can't spell. Stretch by 2. It is twice as tall because there's a 2 there. Now, again, I don't need for you to necessarily do all of this. We're going to jump to this last one, and then I'm just going to make up a couple more. Instead of a 2, if it was a 1/2, what do you think? Use your common sense. It's not going to move up or down. Can you focus?
It's going to stretch up.
But we don't use the word stretch if it's smaller. What word would we use instead of stretch? It's going to shrink by a half. It would be half as tall. Do you get what I'm saying? Stretch, shrink. Let me make up a couple more. Can you just pay attention? Or I'll just write them over here. We'll just call this part F. Say it was 5x squared. What happened to the graph? Stretch by 5. So it would be 5 times as tall. It would be like if I took you and stretched you to 5 times your size. It would be like the kid in Willy Wonka that got like put in the taffy puller. Do you know what I'm saying? Like, all right. Now, what if it was 1/7 x squared? Shrink by what? By 1/7. So it would be like if I compressed you to 1/7 of your size, you would be like all widened out. You get what I'm saying? Here, I'll show you. Look, don't even do anything. Just look up here. I'm going to change it to a 1/7. Watch what happens to this graph. Can you look? Here, do you see that? Do you see how it's really wide now? What if I made it 1/20th? You see that? Okay, what if I made it like 15? See how it got stretched to 15 times its size? It's way taller now. That's all that's happening. All right, last one. Now we're going to graph -x squared. So look up here. I'm going to type in -x squared, gear table. And I would like for you to plot those points. You've got -2, -4, and so on and so forth. I'm not going to read them all to you because you can read. It's not. Plus means up, minus means down. We're going to summarize it all in a second. You got up and down, you got stretch and shrink, and then this is the last one. What do you notice happened to this graph? It flipped. Now, the mathematical word we use is reflected, but if you wrote flipped, I wouldn't mark it wrong. It's going to look like that. So how do the graphs compare? It is reflected or upside down. If you wrote flipped, I would take that, but the correct vocabulary is that it is a reflection. So let's summarize real quick. Summary. Plus means what? If you add to the graph, it's going to move up. Good. Minus means down. That is not that hard. Okay, work with me. Pick a letter of the alphabet that's not A. Let's do A. Say you have ax squared, that's going to be a stretch. If you have a 1/ax squared, That's a shrink. And if you have a negative in front of it, it is a reflection. That's it. Those are the 5 things that can happen. Up, down, stretch, shrink, reflection. What's up? Okay.